Hi everyone, welcome back to Array series. Hope you're doing good. This is Mahesh. In this video, we will continue on the majority element, a Leetcode problem, which is 169th problem. Okay. So what this problem states, there is a given array nums of size n and you need to return the majority element. So what is majority element? It is the element that appears more than n by 2 times. You may assume that the majority element always exists in the array. So there is one element which appears more than n by 2 times always in the array. Okay. So let us try to understand the problem in detail. So we have say n equal to 9 numbers. So this is the given array. We have 9 numbers. Okay. So out of 9 numbers, there is one number in this particular array which appears more than n by 2. N by 2 in the sense 9 by 2, which is 4.5. We will assume it as 4, the rounded number. Okay. So there is always one number which appears more than 4 times, not 4 times, more than 4 times. So it can appear 5 times, 6 times, 7 times, 8 times, or 9 times. Okay. So that is what is this problem states. Now with that, what are the constraints? So basically we will follow these steps. You can refer to these steps. So this is the standard structure where we are going to which we are going to follow throughout this series. So first we will understand problem, then we will understand constraints, then we will pause and we will think for solution and so on. So now if that is the case, we already understood the constraint, right? I mean, there is going to be for sure one number which appears more than n by 2 times. Okay, so that is pretty much clear. So if that is the case, you can pause for a second and you can think for the possible solution here. Okay, so what exactly, I mean, the interviewer will be expecting you to solve this problem. So that is the most optimal problem, which is called Boyer-Moore's voting algorithm. So which we will discuss later, but that will find the majority element in O of n time complexity. Okay. So with that, let us try to understand the brute force solution for this. So what is the extreme naive solution we can think of whenever we say about majority element? So maybe one thing what we can do, we can start looking into any element and then scan throughout the array and count for that particular element occurrence. So in this case, I will start with 2. I will start with 2 and I'll count for the appearance of 2. So 2 appears 1, 2, 3, 4, 5 times. Okay. Now this is greater than 4. So it means 2 is our majority element. This is the best case. We got the first number as our majority element. Assume if that is not the case, then we will have to repeat that process. Maybe assume 2 is not the majority element. If 1 is the majority element, again for 1 we will have to count throughout the array. So here we are considering only 2 numbers, 2 and 1 in this array. There can be more than 2 numbers also. Okay, so that depends. So in this particular scenario, the worst case would be of order n square. Okay, because for each element we count for the remaining elements and that occurs for all the elements. That's why it is of order n square. This is the extreme naive solution. What is the other solution, or maybe a small improvement over this extreme naive solution? The other would be, I mean, we can use hash map. We can use hash map and we can keep the count of numbers. So what we can do, we can iterate over each number, and what we can do, we can increment the count in hash map. Okay, so let us try to do that. Now let's we have some hash map here, okay, so which stores key value pairs. Okay, now I will start with my first number, so 2, it does not exist, so I'll add it into hash map and I will add the count as 1. Next I'll go to next number is 1, then its count is 1. Next number is again 1, so its count become 2. Next is 2, its count become 2. Next number is again 2, its count becomes 3. Next number is 1, then its count become 3. Next number is again 1, so its count become 4. Next number is 2, so 2's count become 4. Next again one more number which is 4, so its count become 5. So 2 appears 5 times, 1 appear 4 times. So if this is our final hash map after the iteration, then what we can conclude, this number appears more than n by 2 times, which is more than 4, means it should be 5, 6, 7, 8 or 9. Okay, so here in this case exactly 2 is appearing 5 times and 1 is appearing 4 times, but there may be case where 2 is appearing maybe 6 times and 1 is appearing 3 times, or 2 can appear 7 times and 1 can appear only 2 times, something like that. So we will have to properly check whether the number really appears for more than n by 2 times. Okay, so this way what we can do, we can come up with the majority element. Okay, so you can think of a situation where there are few candidates who have contested for some election and there will be only one person who will win the contest, right? So if that is the case, that person will get the majority of the votes, means more than 50%, more than 50%. Okay, so we will, I mean, that's a real-time example. So now let us try to understand the pseudocode for this one. So I will take a majority element method. It accepts nums array. Okay, so now what I will do, I will take a hash map, or in some languages it is also called map. So I will name it as counter and new hash map. Okay, so I will keep this hash map. Now what I will do, I will iterate over my array of nums. So I equal to 0, I less than nums dot length I plus plus. Okay, so with this, what I will check, if the number is already there in the counter, then what I will do, I will increment the count. If counter dot get, in some cases it is get in some languages, and in some languages it is get or default. So in JavaScript it is get, and in Java it is get or default. I'll simply take get for now, and I will pass nums of I. So if it contains number, then what I will do, I will simply say counter dot set in JavaScript and put in Java. Okay, so set nums of I, then I need to pass its count. So before that, what I will do, I will take a count variable and I'll use this counter dot get of nums of I, then plus 1 I will do. So I will add that here, I'll write it in next line. So this will set our counter with that particular number. Now what I will do, I will also check if this particular count, is, so let us take 1, or we will simply check if it is greater than n by 2, then what we will do, we will simply return our nums of I, because this is our majority element now, because if it is appearing more than n by 2 times, then it is a majority element and we will return that element. If that is not the case, we will keep adding the value to the counter and we will keep incrementing the value. Then finally we will return -1. So this is just to return from this particular method, because we will get that element from this if condition only. It won't, this particular statement execute, but we want something to be returned outside this if statement. That's why we are adding return -1. So if you see, this is how our pseudocode works for this hashing method. So now what is the time complexity? So if you see time complexity, assume our map executes in order one time for getting and setting the value, or getting and putting the value. If that is the case, our this particular code executes for order of n time complexity, because we are using one iteration, one for loop basically, and with that for loop only we are adding the values to the counter, and then we are checking the condition if it is greater than n by 2, and we are returning the majority element. Now if you see space complexity, it is not order 1 here. We are taking hash map. In worst case, it takes order of n space complexity. Okay, so this is the time and space complexity for this particular problem. Okay, now let us try to execute that and see. Okay, so let's take a counter, and instead of map we will simply take empty object. So for simple use cases, empty object would be sufficient in JavaScript. If that is not the case, in some complex operations, wherever we specifically need get and some other extra methods which hash map provides, that time we can go ahead and use the map here. So I'm using empty object. Then what I will do, now let's take one more variable, constant majority. So this will be math.floor nums.length by 2. This will give the value of n by 2. Now what I will do, I will iterate over the array. So I will use for of loop. So constant num of nums, and then what I will do, I will take a count variable and it will get the count of that particular num in the counter. So counter of num, it will check if there is value, it will take that value, or it will take 0. We can use this syntax. So it is like, it will check if there is something with that particular number in counter. If that is not the case, it will take 0 default. Then I will add 1 to it. So this way it will give us the count. Now what I will do, I will add that to the counter of num equal to the new count. Okay. Then after that, I will check if count is greater than our majority, which is n by 2. If that is the case, simply return our num. If that is not the case, at the end we will simply return -1. Ideally this statement does not execute because we are sure that there is one majority element. So this statement, from this statement only, we will return the majority element. Now let's run this and see. It is accepted. Okay, now I will submit it. If you see, our solution got accepted. Now This solution is pretty much good, right? But is there any way we can improve this particular space complexity, because we are using extra space, right, which is of order n in worst case? So is there any way where we can improvise this? I mean, can we achieve it using somewhere order of 1? There is a algorithm which is called Boyer-Moore's voting algorithm. Basically, it is not algorithm, it is Boyer-Moore's voting algorithm. Okay, so what is that? What is this Boyer-Moore's voting algorithm? So let us assume there are 10 voters. Okay, there are 10 voters and there are two contestants. So the condition is a contestant is a winner if he is having more than n by 2 votes. It means 10 by 2, he should have more than 5 votes, which means he can have 6 votes or 7 votes or 8 votes, 9 votes, or all the 10 votes. So he will be assumed or he will be considered winner. Okay, so if that is the case, assume our voting is done and one contestant got 6 votes, correct, right? And another will get 4 votes for sure, correct, right? So if you see the difference, how much it is? The difference is 2. Now let us try to determine this difference. So what we do, assume, let's take this example only. I will copy this. So here in this case, 9 votes, 2 contestants, okay, and winner will get minimum 5 votes, so which is more than n by 2. Okay, now what I will do, I will take a contestant and I will take the count, or you assume it's a difference, because if he has to win, he has to have a difference of 2 votes, correct, right? Now I will keep them empty initially, let the count be 0. Now what I will do, I will take the first, I will see the first vote. This is for contestant 2. So I will take contestant 2 here, then I'll increase the count to 1. Okay. Now if you take the next element, this is for contestant 1. Let us assume initially contestant 2 is the winner because he will have the majority votes. So with that assumption, we will proceed. Now once we get vote for the next contestant, which is 1, then we will decrease his count. So I'll decrease his count to 0. Okay, so at this particular point, nobody is a winner because both 2 and 1, they have got 1 votes. Okay, I will continue. Now if you see, 1 got 1 extra vote. Okay, so now I will change my contestant, the assumption of winner, to 1, and I will increase the count to 1. Okay, now if you see, again I get 2. So now I will decrease his count. So I will decrease it to 0. Okay, now if you see, again I'll get 2. So it means now 2 is kind of at this point 2 will get more votes. So what I will do, I'll replace my contestant to 2 and I'll put his count as 1. Okay, now if you see, again we will get 1. So it means now I will have to decrease the count because count is greater than 0. Now if you see, again we will get 1. So since this is 0, I'll replace this 2 to 1 and I will add my count as 1. Now if you see the next value, it is 2. Right? If that is the case, then I will decrease the count to 0. So till this point, we don't know who is the winner, because if you see the count, it is 0, right? Now if you see the last element, it is 2. So since this is 0, I'll replace this to 2 and I'll increase the count to 1. Now if you see, there are no elements. At the end we got the contestant as 2, and if you see the count, it is 1. This gives us the difference between the votes of a majority contestant and the other contestant who got the less votes. So if you see here, in this case, 2 has got 1, 2, 3, 4, 5 votes. Correct, right? Now 1 has got 4 votes. Correct, right? If you see the difference, it is 5 minus 4 equal to 1. So that's what we get here. So with this, we will get who gets the majority votes. So that is how, we find the majority element, because here we are sure that we will get one contestant or one number which is greater than n by 2 count. So this does not hold good only for 2 contestants. Even if there are 3 contestants, 4 contestants, there also this pretty much works fine, because even though there are 3 or 4 contestants, one contestant will get for sure more than n by 2 votes. More than n by 2 votes. That's why this logic works. Okay, let us try to look this in pseudocode. So let's take a contestant variable, contestant, and initially just mark it as -1 and count equal to 0. Okay, now iterate over the loop I equal to 0, I less than nums dot length I plus plus. Now you check if count is 0, then what we have to do, if count is equivalent to 0, then we will say our contestant will be nums of I. Okay, so if that is not the case, as usual step what we need to do, we need to increase or decrease the count. So if our contestant is equal to nums of I, then what I will do, I will increase my count. If that is not the case, then what I have to do, I have to decrease the count minus. Okay, so this way what we get at the end, we will get who is our, you just need to return the contestant. So this way we will get the majority element. So if you see, with one iteration and without using any extra space, we are determining the majority element. That's why it is of order n for time complexity, and for space complexity it is of order 1. Okay, let's, now what I will do, I will comment this, let count equal to 0 and our element or contestant, we will say contestant equal to -1 initial. Now what I will do, I will again use for loop. I will use for op for num of nums. Then I will check if my count is equivalent to 0. If that is the case, if count is equivalent to 0, then I will set my contestant to num. If that is not the case, then what I will do, I will check if my num is equivalent to contestant. If that is the case, then what I will do, I will increment the count. If that is not the case, I will have to decrement my count. Okay, so this is how we do, and at the end we will simply return our contestant. Let's try to run this. Okay, this is accepted. Let's submit. If you see, the solution is accepted. Okay, hope you understood this explanation. If that is the case, please consider subscribing to my channel and also like the video and share it with your friends. Thanks for watching the video.